Here's pre-calc. This is problem 9-75. It's partial fraction decomposition. We started this in class ran out of time. So it's partial fraction decomposition revisited. Recall the process of partial fraction decomposition from chapter 3. I believe we were using it to write the rational functions in graphing form. What happens when the denominator cannot be rewritten as a product of linear factors? Complete the parts below to see how matrices and systems can be used to decompose fractions. So, and the reason you need all this is you're going to have to do this all the time in calculus when you're trying to integrate things. You're going to want to get them into a certain form. So it says, consider this fraction and try to decompose the fraction using the method from chapter 3. So I went ahead and tried that. And if you don't remember the method from chapter 3, it's what we do is we break it into the two factors. We can't factor x squared plus 3 anymore. It's an irreducible quadratic, or you can't, it doesn't factor. So we can try writing it like this, which seemed like a good idea, and then we're going to try to get rid of, we just want to get rid of the denominators. So we're going to multiply both sides by x minus 2 times x squared plus 3. And then so on the left-hand side, this will all cancel out, and we just end up with 2x minus 1. But on the right-hand side, the x minus 2 cancels out. We end up with a times x squared plus 3. And the x squared plus 3 cancels out. We end up with b times x minus 2. We want to distribute because we're going to do this thing called equating the coefficients. And I don't know if everybody really grasped that last time we did this, but I need these factored out or distributed out. So I distributed everything out, and then I want to gather them together. Like I want all of the x squareds together. There's only one. There's just the ax squared, and I want the ones that have x's in them next. So I moved this over here, and then these don't have any powers of x in them. So I know it's hard to see. That says 0x squared. So this left-hand side has 0x squared plus 2x minus 3 or minus 1. So we want to equate the coefficients. So on the left-hand side, it's the x squared term has a coefficient of 0. So we know a is the coefficient of x squared over here, so it has to be 0. A equals 0. So it looks like things are going great. The coefficient of x is b over here, and over here it's 2, so b equals 2. So things seem so great. These are the coefficients of, I guess you could say they're the constant term. So we're going to set those equal to the constant term. And then you solve using a system of equations. We didn't know about matrices yet when we did these in chapter 3, so we just used substitution or elimination. Since we know a is 0, I plugged in 0 for a, and since we know b is 2, I plugged it in for b. But then I ended up with something that's not true. So this is no solution, and if you read in the book, that's what it says. It says you get no solution. So that's a problem. So then, but it's okay. The book it's just teaching us right now. So it's going to tell us how can we solve this little glitch that we have. So it says the fraction can be rewritten, and then it shows you how to rewrite it with a bx plus c because you need a linear factor up here. So the problem, part of the problem, without getting too in depth, is that you need the numerator to be 1 degree lower than the denominator. And so this needs to be linear up here since it's quadratic down here. So, and that's what that says right there. Okay, so next it wants us to write a system of equations. So we'll go ahead and do that. So here, I wrote it the way that they asked me to. And now I'm going to rid myself of the denominators. So that cancels out, and I get this, right? Because the x plus minus 2 cancels out, and over here the x plus 3 cancels out, okay? And I'm going to do the same exact process. Going to distribute. I distributed, I had to actually multiply this all out like FOIL. Then I'm going to gather all my x squareds together, so they're like next to each other. All my x's and all my constants. Do I have all? Okay. And then I'm going to factor out the powers of x so that I end up with, I want to know what that coefficient is of x squared. Because remember, this is a 0x squared plus 2x minus 1. So now I know what the coefficient of x squared is. It's a plus b. And the coefficient of x is negative 2b plus c. And then these are the constants. So I could write a plus b must equal 0, because that's coefficient of x squared. Negative 2b plus c must equal the coefficient of x. And I think I rewrote these 3a minus 2c. That's going to have to equal the constant. Okay, and then I was going to just do these by hand, because I feel like I could totally do these by hand, and so could you. I could, use substitution and elimination, but they want me to use my matrices. So, happy day, I'm going to use my matrices. I decided to make an A and a B and a C column. And then, what did I do here? Okay, so I want all the coefficients of A in my column. So this is like 1A, right? And then this one doesn't have an A, so that would be 0A. And then this one has 3A, so there's a 3. And then my coefficients of B, this one's the 1. There's the negative 2. And then this one doesn't have a B, so I had to stick in a 0. So I'm going downwise. And then C, this one doesn't have a C, so I put 0. This one has a 1. And this one over here has a negative 2. And then, because I want to know what A, B, and C are. And then I know those are all equal to my coefficients. Remember the 0, the 2, and the negative 1. And now I see that I probably should have written these lined up, stacked up for you, so that it would be easier to understand. But anyway, I arranged them. And now if you remember, all I have to do is multiply both sides of the equal sign by the inverse of this matrix. And since it's a 3 by 3, I'm going to use my calculator on it. And so here it comes. So I actually just typed in the matrix, and then I typed in the other matrix, and then I told my calculator to go A inverse times B. And I actually got the solutions, hard to see. I'll write them down. So the solutions that came out of my calculator were 3/7, a negative 3/7, and 8/7. Okay, so that's what I got out of my calculator. So that's, here's A, B, and C. And then the last thing, I think I'm going to run out of time, but the last thing I would want to do is write them on top of my my denominator. Okay, so you could write it, and I'll just show you in the answer book how they did it. Remember, it was the 3/7, and then it was the negative 3/7. Can you see that? Wait. And then it was a negative 3/7 plus 8/7. So that's A, B, and C. Or you can clean it up and put the 7s down there. Okay? So that is partial fraction decomposition with matrices.